Hi guys, and welcome back. So in the last video, we took a look at how the worker nodes could be troubleshooted using a couple of different commands in kubectl, and we figured out that there was an issue with the CNI. Now, one of the other issues that you might come across as well could be related to the kubelet service that is running on your worker nodes. And if that kubelet service were to go offline, then that worker node would have no channel of communication between itself and the master nodes, and would therefore not be receiving any instructions in terms of what it needs to do next. So let's take a look at what could happen if one of your kubelets were to go offline. So we'll intentionally fail one of the nodes. And to do that, I'm actually going to go into my AWS console right over here. So let me bring that over here. And in the AWS Management Console, I've got an EKS cluster that I provisioned using the EKS-CTL utility. So it spun up a couple of CloudFormation templates for me. And you don't really necessarily need to know all of these implementation details. However, I would certainly encourage you to get familiar with the major cloud vendors' implementations of Kubernetes if you're going to be using Kubernetes a lot, as each of the cloud vendors provides quite a bit of value, I would say, on top of Kubernetes itself by automating the setup of the master nodes and worker nodes and all that stuff, and dynamically scaling with auto-scaling groups and things like that. It can be really helpful. But I've got a couple of CloudFormation stacks that have been deployed by the EKS-CTL utility. The cluster name is Scrumptious Hideout, and one of these is for the cluster itself. You'll see cluster there at the end of the name, and the second template is the node group, and that's basically just the worker nodes running in EC2 that are being joined to the cluster. And then if you head over to the EKS console here, we should see our cluster showing up in here. And then over in the EC2 console, we can actually see the worker nodes individually as well. So here's my EKS cluster. I can drill in and see the cluster details for that. And then the nodes that are acting as workers based on the node group CloudFormation stack that we just took a look at, that's these two nodes right here. So directly in the console here, you can see under the Overview tab, we have these two nodes. You can see the instance type, which is basically just the CPUs and memory allocations for each of these worker nodes. And you can also see which node group it belongs to. So what we can do now is go ahead and switch over to the EC2 console and take a look at the worker nodes themselves. Now, it can help a lot to have direct SSH access into these nodes. And when you provision them, you can certainly set up SSH access to them. In this case, though, the default is to disable SSH access. And so under the key name over here, you're going to see that there is no public key associated with the user account, so I can't log into those over SSH. But one of the great things about running Kubernetes inside of a cloud vendor is that they have other connectivity tools in order to get access to one of these instances. So really quickly, before I actually get in there and do that, I did just want to kind of point out to you that following on from our last video here, if I run a kubectl get nodes, that should show me that these nodes are healthy. So we are starting from a place of good health here. And what we're going to do is intentionally break one of those. So let's switch back over here. And so it looks like I've got two nodes in the running state here, this one and this one. Looks like this one was terminated, probably because it's just a spot instance that AWS decided to reclaim. But then what we want to do is basically get access to one of these two nodes that's running and joined to our cluster. And then we can disable the kubelet service and see what happens. So if I right click on here and do connect, this gives you a few different options to connect to the EC2 instance. AWS has a feature called EC2 Instance Connect that allows you to establish a remote shell. I don't think I have access to use that though. If I try to do EC2 user, I don't think that this feature is enabled for these worker node instances. So yeah, it says there's a problem connecting to your instance. However, the other options that we have here are to get a serial console on the device, which is one option. You can also SSH, which we already discussed, that's disabled because there's no key pair associated. And then the other option is a service in AWS called AWS Systems Manager Session Manager. And so we can use this feature to connect directly to that instance and get a shell on it so that we can play around inside of that virtual machine. So it's just going to bump us into sh here. I'm going to go ahead and launch bash here. And what I want to do now is just kind of explore the system. So I'll do a sudo systemctl status, and we'll do a status on the kubelet service. So let's get that. And as you can see, the kubelet is currently in an active and running state. So it looks like it's currently healthy. You can see the logs here. You could use journalctl to get the full logs from this component as well. But what we want to do now is actually disable this service and see what happens as a result. So to do that, we can do a sudo systemctl, and then we'll do disable. And we'll do disable on the kubelet service. And as you can see, that symlink for the service controller in systemd has now been disabled. And so if we do a status again, we just hit up arrow a couple of times, you can see it's still in the running state. So we disabled it, and if the system were to restart, then this service would never actually come online. But when we disable it, we don't actually stop it if it's actively running. So what we need to do is manually stop it. So we could do a sudo systemctl and then stop kubelet. All right, and now if we do status one more time here, you should see that it says it's loaded. So technically the daemon, the systemd daemon, knows about this service because it did previously load the service file back from when it was symlinked. However, at this point, it has been disabled, even though it's been loaded, and its current state is inactive or dead, indicating that it is no longer running. So if I run top here, I would normally see that the kubelet is running and using a little bit of CPU resources, but at this point, the only process on the system that's really using any system resources is the systems manager agent that I am connecting through to get this web-based shell onto the system. So now that we've disabled the systemctl server, systemd service for the kubelet, let's see what happened over here in our cluster. So if I run kubectl get nodes again, check it out. This node right here has changed from being ready over to the status of not ready. And so we could do a kubectl describe and just grab this node. So say kubectl describe node, and then paste in the name of that node that we want to describe. And as you can see, it says the last log entry is actually node ready. So the last message that the master nodes received from this node was that it was ready. However, when we killed off the kubelet service running on that node, it became no longer ready. So one of the things that you can see right up here is under these events here, it's actually sending a message called node status unknown, and it said kubelet stopped posting node status. So there's kind of this ongoing health check in the kubelet that's reporting a positive or healthy status back to the master nodes, but the master nodes have actually detected that that heartbeat is no longer appearing from this node, and so therefore this node must be presumably offline entirely. So, Kubernetes doesn't know if it's still on the network, if it's still running, a VM that's in a running state or stopped state maybe, or maybe somebody just completely deleted the virtual machine. At this point, Kubernetes does not really know what is going on, hence the name node status unknown. So if we wanted to do some health checks on that node to ensure that it's healthy, one of the things that you can do is go to your cloud vendor's console and just check the status of the virtual machine. Make sure that the virtual machine is in a running state. Let me just bump the font size down here just a little bit. And as you can see, both of our nodes are still in the running state. We can see that if I just do a refresh here, yep, both those nodes are still in the running state. So we know that the virtual machine is up and running. One of the other things that you could do as well is try to maybe spin up another virtual machine on the same VPC and then try to ping the private IPv4 address of this node to see if you have ICMP connectivity to it. That could be another kind of network level test that you could perform against the virtual machine. Once you verify that it's running, then you could try to ping it. And then, of course, you could try to access the console like we already did over here. You could come back into the console on that virtual machine. And then at this point, once you have a shell on that remote VM, you could do sudo systemctl status on the kubelet service, and oh, check it out. It looks like it's inactive. So this right here is the indicator that the kubelet is not running on the system. Again, you could run top and just look for kubelet in the list of processes, or run a utility like ps, for example, ps.-aux here, and then you could grep through this and look for kubelet, or just part of kubel. And oops, I actually need to grep. And so as you can see, the only process that's running is grep with that text. So obviously that's not the actual kubelet process. And so this right here would indicate to us like, okay, well, I don't see the kubelet process running. So then, once again, you would check the status of the service and say, okay, systemd reports that it's not running. And so it says that it's loaded, so the daemon knows about it. But if it didn't say loaded, so if this service was not loaded, you'd probably see something like, let's do a systemctl daemon -reload. That'll just force the daemon to reload for systemd. And then if we run status again here, it looks like it's still loaded, but if I was to reboot this system entirely, this would probably not be loaded because we disabled the symlink for this particular service. So it should not be loaded by systemd any longer at startup. So in any case, we want to get the active status from inactive to active once again. And so to do that, we can see that it's currently in the disabled state. And the first thing we would want to do is to enable the service. So we do systemctl, and then just do enable, and then kubelet. And as you can see, that recreates the symlink on the file system so that the systemd daemon, when it boots up on the system, it's going to check the directory and make sure that the the service unit file is being linked into the proper directory so that it can load it. And then, of course, we don't want to also manually start it as well. So we could do sudo systemctl start kubelet. And now, once it's started up, we can do a status on it again. As you can see, the active status has changed from inactive to active. And you can also see that right here under the loaded section, it's now set to enabled instead of disabled. And then finally, once we've done that, we can come back to our local terminal here, and we could run a kubectl get nodes, and we should see that status change over to ready. And sure enough, that node is now in the ready state. We could do a describe on it as well to get additional details about that node. And if we scroll up just a little bit here, you should see that we have this event here, says kubelet ready, and it says kubelet is posting ready status. So it's returned to a healthy state. So that's kind of the process that you would go through to troubleshoot the kubelet running on a worker node in your Kubernetes cluster. I hope this has been informative for you, and I'd like to thank you for viewing.